Let us continue the next application of derivatives, that is maxima and minima. To come to know that what is maxima and minima, you have previously already know that increasing and decreasing. We should have the basic idea about the increasing and decreasing. If you know that and if you are clear with increasing and decreasing, we can easily know that what is meant by maxima and minima, and so many applied questions will arise on based on this topic. Okay. Anyhow, directly I just go to the definition of the maxima and the minima. After seeing the definition, we will come to know that geometrically what is the meaning of that one. Anyway, here let f is the any real valued function. F is the any real valued function defined on an interval I. I given any interval, f is a real valued function. Already know that real valued function means function range, and range is the set of real number or subset of the real number. F is a real valued function defined on an interval I. Then we can say that first case f has a maximum value. F has a maximum value on an interval I. F has a maximum value on an interval I. When it is said to a maximum value on I means whenever C is any point. C is any point. One more point we can add it here. C is the any point belong to the given interval I. C is the any point belong to the given interval I, or C is the point in a domain of the definition. Then f has a maximum value. When it is on an interval I, that is whenever f of C is greater than f of x. F of C is greater than f of x for all x is belong to the given interval I. Then we can say that f of C is the maximum value. F of C is the maximum value, and C is said to be a point of maximum. C is said to be a point of maximum, and f of C is the maximum value. Already you know that this relation f of C is greater than f of x. F of x1 is greater than f of x2. Then the function is said to be an increasing function. And f of x1 is less than f of x2. Then the function is said to be a decreasing function. Okay. Anyway, let's move to the next one. I will explain afterwards. Anyway. So next condition, let f is a real valued function defined on interval I, and where C is belong to the interval I, then f has a minimum value. F has a minimum value on an interval I. When it is has a minimum value, reverse. That is f of C is less than f of x. F of C is less than f of x for all x belong to the given interval I. For all x belong to the given interval I. In this case, f of C is said to be the minimum value. F of C is said to be a minimum value, and C is said to be a point of minimum. Point of minimum. Next, the third case, f has a extreme value. F has a extreme value. When it is said to be f of has extreme value means f has a extreme value. When it is has a extreme value, then there exists a point C in such way. Then f has either maximum value, either maximum or minimum values. In that case, f has said to be a either f has a maximum or minimum value. F of C has a either maximum value or minimum value. In that case, f has a extreme values. Anyway, so let's come to know that these 3 points geometrically will come. So this definition, alteration we can do that. That is, f has a maximum value on an I. Then there exists a point C. I have already taken. That is C belongs to I. Then there exists a point C. If there exists a point C, then f of C is greater than f of x, and f of C is said to be a maximum value, and C is said to be a point of maxima. In the same way, f has a minimum value on an interval I if there exists a point C on an interval I such that f of C is less than f of x for all x belong to the given interval I. In that case, f of C is a minimum value and C is said to be a point of minimum. And f has an extreme value, extreme either maximum or minimum. Then f of C, then there exists a point C belong to the given interval, then f of C is either maximum or a minimum. Okay, anyhow, let's come to know that clear picture of these words by graphically. How I just take means, suppose in a xy coordinate plane, suppose the function having the graph like this. In a xy coordinate plane, suppose the function having the graph like this. So I just say that y is equal to f of x. It is a real function. Is that this function? Real valued function define an interval I. Interval I is that this is the interval I from A to B. Only n points are given A to B. That means open interval I is that. What is the open interval I? I is equal to open interval A comma B is that. That means function domain is open interval A comma B. Range is from here to here. Anyway, so function y is equal to f of x is a real function. Define an interval open interval A comma B. Now observe this graph as the basic knowledge of increasing and decreasing. If I changing the x values from A, increasing, the y value is also increasing, and the certain value that attains the maximum, or else we can say that here it is a curve is changes its direction from increasing to decreasing. Curve is changing its direction from increasing to decreasing. This is the point. At this point, I just draw one perpendicular to the x-axis. That point I just call it as a C. That point I just call it as a C. So x is equal to C is attains the. Now observe that this value y is equal to this point. We can say that f of A, and this value we can say that f of B, and this value we can say that f of C. Just observe that f of A value, f of B value, and f of C value. Out of these three values, which one is greater value, or which one is the maximum value? F of A value is nothing but y value. This much value is the f of A, and f of B is nothing but this is the f of B. This is f of A, and what is the f of C? This is the f of C. Which one is maximum out of these three values? F of C is the maximum. Now go back to the definition. F is a real valued function on I. F has maximum value on I. F has a maximum value on I if there exists a point C. There exists a point C and an interval I. Yes, C belongs to the interval A comma B. C is lies in between A and B. C belongs to the interval A comma B. Then there exists a point C. Okay, then f of C is greater than f of x. F of C is greater than f of x. X value we can choose any value in the interval A comma B. So the condition is satisfied here. F of C is greater than f of x. F of C is greater than f of x. So first condition is satisfied. That is f of C is greater than f of x for all x belong to the interval I. Therefore, f of C is the maximum value, and C is said to be a point of maxima. This is the first one. Now, come for the second thing. Suppose in a xy coordinate plane, I just consider this y is equal to f of x might be like this. I'm not taking the exact diagram, roughly I'm just taking. So this value we can say that from the A, and this value x value is a B. Okay. Function is y is equal to f of x be a real function on defined on interval I. Then there exists a one point C in the interval I, then there is a one point C in the interval I. What is that point? This point is the C. This point is the C, which is belong to the given interval I, A comma B. Then here has a minimum value on I whenever there exists a point C such that f of C is less than f of x. Now observe that on increasing the x values, function is decreasing. At x equal to C, it changes its direction, then again it is increasing. So that this point, we can say that f of C, and this value here is a f of A, and here it is a f of B. Just compare the three values. If you compare these three values, what we say that which one is the maximum value? F of A is maximum, or f of B is maximum, or f of C is maximum. So that here we can say that f of A is maximum. So that means I need to come to that minimum value. F of C is the minimum value whenever it is satisfying the condition f of C is less than f of x. This one is the less as compared to the f of x, as compared to the remaining all these values. In that case, this value f of C is said to be a minimum value and C is said to be a point of minimum. Next, the third one is that, what is the third one? Suppose in a xy coordinate plane, origin is that has the extreme value is that. Extreme value, I just say that suppose the function is defined in this manner. This is the A value and here it is a B value is that. So what is the maximum value and what is the minimum value? It has both minimum as well as the maximum, or else say that f of C has the either maximum value or a minimum value. At this point it has a maximum value and at this point it has a minimum value on the interval A comma B. So that it is said to be a f of C has either maximum value or minimum value. Particular example of this problem, we can say that graph of the sine function. If or graph of the cos function. What is the graph of the sine function? Sine function graph is like this, oscillating in between -1 to +1. Cos function, I just write in a dot, or else I just write here. What is the graph of the cos function? This is the graph of the cos function. Cos function lies in between -1 to +1. Range of the cos function minus range of the sine function -1 to +1 lies in between -1 to 1. So here observe that there are maximum value, minimum values are there. So here this type of function is that extreme values of the function. There are maximum values there as well as the minimum value is there. If the function has both maximum and minimum value, such function we will say that extreme value of the function. If the function has only one value, maximum value, that is said to be a maximum. F of C is the maximum value and C is the only point. C is the point of maxima. If the function has minimum value, then F of C is the minima and just the point C is said to be a point of minimum. On seeing this graph, we can easily get the clear picture of the definition. Once again, let us see. Let f is a real valued function defined on an interval I. Then f has a maximum value on an interval I. If, when it is if there exists a point C on an interval I such that f of C is greater than f of x. This inequality must be observed to get the maximum value. Then f of C is the maximum value and C is the point of maxima. Then to discuss or to find the minimum value, this inequality must be there. Here f of C is the minimum value and C is a point of minima. If it has both maximum as well as minimum, that is said to be a extreme value of the function. Just note down this definition and corresponding graph, you can easily get the point. And let's move to the next example, or based on this maximum minimum, let us take the examples. Example on the definition of maxima and the minimum. Find the maxima and minimum value, maximum and the minimum values if any. If there exists a maximum or a minimum, if both are exist, find that value of the following functions given by f of x is equal to x square for all x belongs to R. As we see in a definition, f is a real valued function depend on an interval I, and there exists a point C. There exists a point C which is belong to the interval I. Then f of C is greater than f of x. Then f of C is the maximum value. F of C is less than f of x. Then f of C is the minimum value. And if both maxima and minima exist, then it is said to be a extreme value. Okay. According to these two definitions, what we have to find? Here interval is given, but here whole real number is given. Whole real number set. That means whole real. For example, xy coordinate plane is the. This is the x-axis positive infinity, and it is a negative infinity. Here it is a 0, and this is the y-axis is the x-axis and the y-axis. Already know that f of x is equal to x square, which means that can I say that y is equal to x square? Y is equal to x square, or x square is equal to 4ay. X square is equal to 4ay is nothing but what? It is a upward parabola. X square is equal to 4ay. It is nothing but a upward parabola. The parabola is like this. We have a particular graph of the function f of x is equal to x square, or y is equal to x square. X square is equal to 4ay form, so it is a upward parabola. So we can say that f of x is equal to x square, or y is equal to x square is this is the function. Now for this function, we need to find that maximum as well as the minimum values if any values are exist. Then how do you find that? On seeing this graph, we can easily say that whether it exists a maximum value or minimum value or both. So which values exist at here? Here only the minimum values exist. How? See, it is of the second form. Second form, I have taken a graph for xy coordinate plane in this form. The graph is in this manner. If we extend, x value is increasing, the function graph is also increasing on both of the sides. So that because the whole real number set is that we have to take up to infinity. So here this is the x value is decreasing. Here it is goes on increasing. Here also it is function value is increasing. Height of the graph is increasing. But at the 0, the function value takes as a 0. Observe that function is x square. X square is always greater than or equal to 0. X square value is always greater than or equal to 0. Whatever the x value, we can choose a negative real number or positive real number. Whatever the x real number value, we can take it on the domain of the function. It is always positive. It is always positive means, so we get a minimum value. What is that minimum value? 0 is the minimum value. X square is always greater than or equal to 0, which means that f of x is greater than or equal to 0, which means that a function might take the values 0 and more than 0. Function might take the values 0 or more than 0. 0 or more than 0. That means we will get the minimum value. Therefore, f of x has the minimum value. F of x has the minimum value. What is that minimum value? That minimum value is f of c is equal to 0 at c is equal to 0. Minimum value is 0 at a particular point. C is equal to 0. Is it possible to find the maximum value? It is not possible because on increasing the x value, function value is also increases. We can't get the fixed the maximum value. Therefore, only it exists. Only the minimum value. The minimum value of the function is 0. Therefore, minimum value of the function is 0. There does not exist any maximum value. Okay. Next one is f of x is equal to mod of x for all x is any real number. F of x is equal to mod of x for all the real numbers. Again, we have a graph of this function, modulus function graph. We know that modulus function. This is the graph of the modulus function. Here f is real valued function on a particular interval. Instead of particular interval, they have given a whole real number set. On a whole real number set, it is that. Okay. Now, once again, the same thing as the previous example. F of x is equal to x square. Here, f of x is equal to mod x. As its values are increasing, function value is also increases. Here, x value. So here it is decreasing. Here it is increasing. That means maximum value, maximum value. You cannot get the particular or fix it. This is the maximum value. You cannot fix that one. So that here it is a minimum value. Is that how to get that one? Yeah, mod of x is always greater than or equal to 0. Therefore, f of x is always greater than or equal to 0. Function value takes either 0 or more than 0. Less than 0, which is not possible to take it. Therefore, f of x has a minimum value. F of x has the minimum value, that is f of c is equal to 0 at c is equal to 0. C is the point of minimum. C is the point of minimum. In the same manner, let's take the next example. What is the next example? Means f of x is equal to 2x minus 1 whole square plus 3 from the exercise. Find the maximum and minimum values if any of the following function, that is in that third one or in the exercise first problem. In the exercise first problem. This function f of x is equal to 2x minus 1 whole square plus 3 is there. Which is of the form x square plus 3 or shifting of origin will get it anyway. So here once again, however, observe that we need to find either the minimum value or maximum value or both if any exists. What is the domain of the function? Here also domain is all the real number. It is real value function depend for all the real numbers. Okay. Now, as a state, instead of the whole function, I just consider only the 2x minus 1 whole square. 2x minus 1 might be 0. Whole square is that. Whole square is nothing but it is always a positive quantity. 2x minus 1 whole square is always a positive quantity. Do you agree? Because negative number, whole square, positive value, positive number, whole square, positive value. So it takes always a positive value. Next, but f of x is plus 3 is that. 2x minus 1 whole square plus 3 is that. Adding forward by 3. If I add 4 by 3, what happens? 2x minus 1 whole square plus 3 is greater than or equal to 0 plus 3. Now, what is the left hand side value? This value. What is this value? This is nothing but f of x. F of x is greater than or equal to 3. Function value is greater than or equal to 3, which means that function might take to the values more than 3 and the more than 3, less than 3, which is not possible to get for any real values. X you can replace it, negative, positive, whatever value you can replace in the function value, then the function will get the minimum value is 3, more than 3 only will get it. That means therefore we can say that f of x has minimum value. F of x has a minimum value, that is f of c is equal to a. We can easily find the minimum value. For example, this value equal to 0, we will get the minimum value. In the next classes, we will get the point of minimum also. Now, we just come to know that how to find the maximum and the minimum value whenever the whole domain set is the whole real number set is given in that case. Next example. F of x is equal to minus times of x minus 1 whole square plus 10. F of x is equal to x minus times of x minus 1 whole square plus 10. Once again, we need to find the maximum or minimum value if it exists. Okay. Here, function value is minus times of. This minus is outside the square. X minus 1 whole square plus 10 is there. First of all, I just consider only the x minus 1. X minus 1 whole square is always positive, greater than or equal to 0. Do you agree? x minus 1 whole square is always greater than or equal to 0. Square is that, so it is a positive. But here minus is the into. So multiplied by negative. Multiplied by negative, then inequality will be reverse. If I multiply by negative, x minus 1 whole square, inequality will be reverse. Already know that. For example, 2 is greater than or 3 is greater than 2. 3 is greater than 2. We will agree. Multiply by minus. What happens? Minus 3, minus 2. Which one is larger? Here in this case, minus 2 is the larger. Already know that properties. If I multiply the negative quantity to the inequality will be reverse. Okay, anyway. Here, inequality minus is multiplied, inequality will be reverse. First, and next I need the plus 10. So add by 10 on both sides. Minus times of x minus 1 whole square plus 10. 0 plus 10 is 10. What is the left hand side value? Left hand side value is f of x. F of x is less than or equal to 10. F of x is less than or equal to 10 means for whatever the real number function is going to take the values less than or equal to 10. 10 or less than 10. 10 or less than 10 is nothing but maximum value is a 10. Function might be take maximum 10 or less than 10, which means therefore we can say that f of x has a maximum value. Here it is a maximum value, that is f of c is equal to 10. 10 is the required maximum value of the given function minus times of x minus 1 whole square plus 10. Are you clear? Very simple. First of all, we have to see the function. Next, in the same manner, next one. F of x is equal to x cube plus 1 for all x belong to the real number r. F of x is equal to x cube plus 1 for all x belongs to the real number r. So here x cube plus 1 is there. Already know the graph of the function f of x is equal to x cube. What is the particular graph of the function x cube? X cube graph will get in this manner. We have a graph of x cube function in this manner. In the first relations and function, 7 type of the function is taken. In that function, polynomial function, graph of the x cube function is taken. So here, this is the graph, or else x value or when you write y is equal to x cube, keep on changing the x value 0, 1, 2, 3, minus 1, minus 2, minus 3, corresponding y will plot the graph, will get it. But here, function value is x cube plus 1 is that. X cube plus 1 is nothing but x cube plus 1. F of x is equal to x cube. This is x cube plus 1 is nothing but shifting of origin. This is error. That means it intersects at the 1. The graph of the x cube plus 1 is like this. Graph of the x cube plus, this is the x cube plus 1. This is the x cube. If x is 0, y value is 1. If x is 0, y value is 1. That means 0, 1. This is how. Now, x cube plus 1 is. On seeing graph of this one, I just rub the x cube graph. Okay, on seeing this graph, you can easily say that it has a maximum value or a minimum value. So, is it a minimum value or maximum value? It has both maximum as well as a minimum. We can say that neither maximum nor minimum. We cannot find the minimum value. We cannot find the maximum value. How to say that? So that here I need to prove mathematically. That is, we can say that x cube, graph of the x cube, lies in between minus infinity to plus infinity. Lies in between minus infinity to plus infinity. Function value, minimum value is, or it goes up to negative infinity and it goes up to the positive infinity. Now plus 1 is required, adding through by 1. So minus infinity plus 1, x cube plus 1 and infinity plus 1. This is same. So now minus infinity is less than, f of x is less than infinity, which is nothing but f of x is lies in between minus infinity to plus infinity. f of x is lies in between minus infinity to plus infinity, means neither maximum nor minimum. So f of x has neither maximum nor minimum, neither maximum nor minimum values. Now, next one is f of x is equal to sine of 2x plus 5 for all x belong to the real number r. F of x is equal to sine of 2x plus 5. Okay, we have already known the graph of the sine function, but here sine of 2x is the none other than same sine of 2x, whatever sine of theta, y is equal to sine theta, or f of x is equal to sine of x. Here sine x. Graph of the sine function, we know that. What is the graph? This is the graph of the sine function. Okay. Here in place of x, we have a 2 into x product. Multiples of 2 is that. Nothing to worry. We get the same. And plus 5 is there. Here, just the sine function range, we know that. What is the range of the sine function? It lies in between minus 1 to plus 1. Sine function is lies in between minus 1 to plus 1. This is the problem how we do as like x square plus 1 or x minus 1 whole square plus 10. This type of problems is already solved. In this manner we want to do. So here we know the range of the sine function. What is the range of the sine function? Range of the sine function is minus 1 to plus 1. That means only the sine to x lies in between minus 1 to plus 1. So plus 5 is required. Sine to x plus 5. Adding 4 by 5. If I add 4 by 5, what happens? Minus 1 plus 5 is less than or equal to. Sine of 2x plus 5 is less than or equal to 1 plus 5. Minus 1 plus 5 is 4. 4 is less than or equal to. Sine of 2x plus 5 is less than or equal to 6. That means 4 is less than or equal to, what is this value? This is nothing but f of x. F of x is less than or equal to 6. Therefore, f of x has maximum as well as the minimum value. F of x has the minimum value. What is the minimum value? That means f of x value lies in between plus 4 to plus 6. This function value lies in between plus 4 to plus 6 in that value. So minimum value is 4 and the maximum value is, what is the maximum value? Maximum value is 6. So that is neither maximum nor minimum. Both the values are there. So that this type of function is say that neither maximum or nor minimum values. I just stop here. In the next video, we'll take the one more definition: local maxima and local minimum. Okay, thank you.